All right, in this video, we are going to work through verifying the following identity. The identity is tan x plus cotangent x over cosecant x equals secant x. Okay? All right, and so what I want to do is generally start on the more complicated side, which is this left side over here, right? And figure out what to do from there. So looking at it, there's nothing super obvious like simplifying that I could do, like multiply um, or combine fractions or anything like that. So what I'm going to do is to just go ahead and switch all of these trig functions on the left-hand side, the tangent, the cotangent, and the cosecant. I am going to change those into sines and cosines using the identities that I know about those. All right, so tangent is sine over cosine, cotangent is cosine over sine, and cosecant is 1 over sine. So I am going to go ahead and do that. All right, so tangent is sine over cosine. Cotangent is cosine over sine. And cosecant is 1 over sine. All right. And so by doing that, that now gives me a lot of things that I can do. Okay. So the things that I want to do here, what I've got is a complex fraction, right? That is a fraction that has fractions in the numerator or denominator. Okay. And so if you have a complex fraction like this, what you can do is make it not a complex fraction, right? So and to do that, I'm dividing two fractions here. All right. So in order to divide two fractions, here I've got this fraction up here, sine x over cosine x plus cosine x over sine x, right? That would be the same, and I'm dividing it by 1 over sine x. That would be the same as multiplying the expression on top by the reciprocal of the bottom, right? Because that's how you divide two fractions, right? To divide two fractions, you take the top, right, part, or the first fraction, and change it to multiplication, and you multiply it by the reciprocal of the bottom one. So writing that out, that would be, and now this we'll have to go in parentheses temporarily because we haven't added the two fractions in the top yet. So that would be sine x over cosine x plus cosine x over sine x times sine x over 1. Okay. So again, here we have this top part, and we're dividing by a fraction, right? When you divide by a fraction, it's the same as multiplying by the reciprocal, all right? Okay, and so when I do that, then now that becomes a little bit easier to deal with. Oops, and I forgot to tag along the secant x, but I'm going to run out of room rapidly here, so I'm just going to not write it in this one. Okay, so now I've got sine x here, right? And sine x over 1, that is the same as just sine x, right? And I need to multiply it times the stuff that's now in the parentheses. In order to do that, I'm going to distribute, right? I'm going to multiply sine x over 1 times the cosine x over sine x term, and I'm going to multiply sine x over 1 times sine x over cosine x. So that's the next step that I can do. So I'm using the distributive property, right? So that's going to be sine x over cosine x times sine x over 1. All right, and then the plus, and then I'm going to multiply sine x times this. So that's going to be cosine x, sine x. That's going to be sine x here over 1, like so. Okay, so next up, I'm going to go ahead and carry out those multiplications. So looking over here at this multiplication, on top, I have sine x times sine x, so that's going to be sine squared x. And on the bottom, I have cosine x times 1. That's going to be cosine x. Okay. All right, and over here, I have sine x and sine x. I have a common factor, right, of sine x between the numerator and denominator, so I can cancel those out since everything's multiplication here on this multiplication. And so I'll wind up with cosine x over here over 1. Okay. Okay, so it's looking a little bit better now, right? And what I've got now left over, I don't have a complex fraction anymore, right? But I do have two fractions that are being added together. All right, and so that basically leaves me something else I could do to try and get over here to secant. And that would be to add these two fractions together, right? So I want to combine these two fractions. Unfortunately, these two fractions don't have a common denominator, right? So what I'm going to have to do is to get a common denominator. So again, I'm kind of running out of room, so I'm going to move up here to the top. Okay, so I want to add these two fractions together. And so looking at their denominators, which are not alike, right, I need to get a common denominator. Well, this fraction has a denominator of 1. So that means that since there's only one other fraction I'm adding, cosine x, that cosine x is going to be the LCD here. Okay, so the LCD is cosine x. All right, and so once I've determined the LCD, all I need to do is to go to each one of these fractions and look at their denominator, right, and ask myself, hey, what would I multiply this denominator by to get the LCD, right? Well, they're the same, right? So it would be 1. And so here with this fraction, I don't need to do anything. It already has the LCD, so I'm good to go. All right, looking at the next fraction, I look at its denominator and say, hey, what would I multiply this denominator by to get the LCD? And it is cosine x, right? And so what I do then is multiply that denominator by cosine x. But to keep everything balanced out, right, I would need to also multiply the top by cosine x as well, right? Because cosine x over cosine x, that's equal to 1, right? So you're not changing the value of this expression, only the way it looks, okay? All right, so next up I would actually carry out those multiplications. With this one, I don't need to do anything because it already had the LCD. With the second fraction, I would go ahead and do the multiplications. Cosine x times cosine x is cosine squared x. And cosine x times 1 is just cosine x. All right, and so now just take a look at what we've done there. We made it so that these two fractions that originally did not have a common denominator, now they have a common denominator, right? And that's good because that means that we can combine them into a single fraction, right? So when you add two fractions with common denominators, you just add the tops. So sine squared x plus cosine squared x. Right, and then keep it over the same denominator. Okay, so we now have this expression combined into one single fraction, which is good. And then looking at the top right, we can see right there, that's the fundamental identity, right? The fundamental Pythagorean identity, sine squared plus cosine squared. And we know that that is equal to 1, right? And so what we would do is then just replace sine squared plus cosine squared with 1. All right, and now you can see, right, we were trying to sort of match the right-hand side over here. We know that 1 over cosine x, right, is equal to secant x. So we can use that identity there. Okay. And that establishes or verifies the identity, right? Again, we only worked over here on this left-hand side. And so in this case, this was an example where if you just kind of look at this expression, you might not see, it's definitely more complicated than the right-hand side, but just in and of itself, you might not see what it is that you need to do. But switching to sines and cosines, right, changed a lot of that. When we switched to sines and cosines, right, we got this complex fraction, right? And one of the things about complex fractions like this is that you can change them to where they're not complex fractions, right? And that's what we did. We did division by fractions and the distributive property, so just use some algebra. Then we got down to these two fractions. And then another thing we did here was combine the two. So it was a lot of algebra for a while until we started using these identities at the end. Okay, and we worked only on the left-hand side here as well to transform it into the right-hand side.